Hello students, in the last class we have discussed some basic characteristics of sound, and now we are proceeding with the speed of sound in different media. Actually, the speed of sound depends on the medium, whether the medium are solids, liquids or gases. Since the propagation of longitudinal waves is more in solids and less in gases, therefore the speed of sound changes in solid, liquids and gases. So the speed of sound is greatest in solids, least in gases and moderate in liquids. So speed of sound depends on the nature of material through which it travels. It's slowest in gases, faster in liquids, and fastest in solids. Here I have prepared a table for the speed of sound at 25 degrees centigrade for the different substances in different states like solids, liquids and gases. So here you can see the aluminum is a solid and its speed at 25 degrees centigrade is 6420 meter per second. So this is the speed of sound in aluminum. In steel it is 5960 meter per second. In glass it is 3980 meter per second. In methanol, which is in liquid form, is 1103 meter per second. In gases, in hydrogen it is 1284 meter per second. In air at 25 degrees centigrade it is 346 meter per second, and in sulfur it is 213 meter per second. So this chart gives you an idea about the speed of sound at 25 degrees centigrade, but most probably in case of air we are using some other value. Actually, in case of air, sometimes in numerical problem you have to use the speed of sound of air at 22 degrees centigrade. 22 degrees centigrade is the ideal room temperature, or ideal practical environment temperature. So at 22 degrees centigrade the speed of sound is 344 meter per second. 344 meter per second. So this is another point to remember in this topic. And the second characteristics of speed of sound, it increases with rise in temperature. Here you can see at 22 degrees centigrade the speed of sound in air was 344, and if we increase the temperature by 25 degrees centigrade then the speed becomes 346 meter per second. That is, there is an increase with the rise in temperature. So speed of sound increases with the rise in temperature. Also it depends on humidity or nature of moisture in air. So speed of sound increases at humidity of air increases. Humidity of air increases. Also, no any physical object can attain the velocity of light because velocity of light is faster. So the speed of light is faster than speed of sound. This is another physical fact. Speed of light is faster than speed of sound. So this was an important topic, and you have to remember the values, especially for air and oxygen. Most of the cases you have to solve the problem related to speed of air. So it's at 22 degrees centigrade, it's 344 meter per second, and at 25 degrees centigrade, it's 346 meter per second. So this is the facts related to speed of sound in short. Now the next topic is sonic boom. Sonic boom is actually an explosive noise caused by shock waves. Few aircraft, bullets, rockets have supersonic speed. Few aircrafts, bullets, rockets have supersonic speed, and when these crashed from the sky, there was an explosive noise. And those are called shock waves. And these shock waves produces sound, and that sound is called as sonic boom. So supersonic refers to the speed of an object which is greater than the speed of sound, and it produces extremely loud sound waves. Called shock waves in air. Sometimes when the aircraft crashed the sky, you definitely feel this sonic boom, or a very explosive noise, a very explosive noisy sound after crashing the aircraft from the sky. So that noise is nothing but sonic boom. And these shock waves produce sonic boom. Somewhere it is asked what is sonic boom, so it was an important topic to discuss here. The next is reflection of sound. Next topic to understand is reflection of sound. So like light, sound also bounces back when it falls on a hard surface. There is a property of light. When light strikes with a hard surface, it comes back from that surface. And the similar property was held by sound. So there is the reflection of sound. To prove the reflection of sound, let us take an experiment. Here I am trying some kind of experimental procedure for the experimental sound. Suppose here is a wall. Here I am just making a wall. I am using two pipes. These are the hollow pipe. Suppose here I put a stopwatch. Suppose here I put a stopwatch. Stopwatch is a physical instrument to measure the time in laboratory. These are the pipes. This and this one are pipes. Suppose here somebody placed his ear to listen the sound. So the tick tick sound of stopwatch traveling through this pipe strike to this wall and again bent with the same angle. Suppose here is some angle of incidence and some angle of reflection, like in light. Strikes with this wall and came back to this ear, human ear, and one can easily listen the sound of this tick tick here. So this experiment proves the reflection of sound. So this is the simplest possible experiment that one can do in lab using a stopwatch, two pipes and wall. So I am not going in the detail of this experiment. I have just illustrated the reflection of sound by meaning of this experiment. So let us write down some theory part of reflection of light. So like light, sound also bounce back. And it is called reflection of sound. Reflection of sound. Also, in case of light, the laws of reflection that was hold in case of light hold for the sound also. So laws of reflection holds true for sound. That means the incident sound wave, this one is the incident sound wave, and the reflected sound wave, and the normal at the point of incidence lie in the same plane. Here the incident wave, reflected sound wave and normal, these all three are lie in the same plane. And normal at the point of incidence. lie at the same plane. And second, that was in case of light 2, the angle of incidence is equal to the angle of reflection, or the angle of reflection is equal to the angle of incidence. Angle of incidence. So it was a very simple example to prove the reflection of sound.